Welcome back to our series on the 8 disciplines. As we saw last time, there are 9 steps to the 8D process, beginning with D0, which is gathering preliminary information. D1 is selecting the team. D2, defining the problem. D3, containing the problem. D4 is identifying root cause. D5, identifying corrective action. D6, implementation of the corrective action. D7, identifying means of preventing recurrence of the problem. And D8, congratulating the team. Now, over in D0 preliminary data, what we're doing is we're gathering data very shortly after the defect is found so that we can capture critical info that could be lost with time. So, for example, the machine the part was manufactured on or used on, the operator involved, batch details, batch level details, the time of the failure, any unique processing conditions or other special circumstances. And what we're trying to do is assess a high level who, what, where, when, why, and how, and whether or not the 8D methodology is appropriate for the problem that we see. Now, over at sixsigma.org, we do have an 8D template developed in Excel that walks us through the methodology. So let's go over there now. This is our 8D template in Excel, and you'll notice along the bottom there's a D0 tab, a D1, D2, D3. When we get to D4, we have a D4.1, D4.2 format. Now D4 is root cause, and the reason we have one tab or many tabs for D4 is that there's many root cause tools, and so we've dedicated a tab for each of those tools. So to get started, we just click on this hot link. It takes us to the D0 tab, and we start filling out the information. The customer, the name of the customer, the address, the location. If they have multiple locations, we want to make note of the location where the problem was found. The date and time of failure, the part number or description of the failed part, lot or batch number details if those are available, failure rate. This could be both the historical failure rate or the failure rate being experienced by the customer. Tracking number is the commercial carrier's tracking number. Parts are coming back to the factory for evaluation. The product name, the application or description of where the part's being used, the person who first reported the failure, the product or process manager where the part is manufactured, the value stream manager if that's appropriate, and then the cost of the failure or lost sales. So let's go back over to the presentation. The next phase after D0, of course, is D1. This is where we select the team. And I want you to note that team member selection is based on the SIPOC model. Now, SIPOC is an acronym that you may not be familiar with. It stands for suppliers and inputs to a process with outputs and customers. And so for team member selection, we want to select suppliers of the process. This is the process where the part is manufactured. We want on the team customers of that process. We want process representatives, operators, supervisors, this sort of thing. Subject matter experts, SMEs. This could be engineers. Most likely it is engineers or quality people. QA, quality assurance people, and then others as necessary. I will highlight, though, that smaller teams really are desired here because they're easier to manage. They respond faster to new data and management requirements and this sort of thing. And we do tend to get better team member participation in small teams. Now, there's 2 things I'm looking for in a team member, both attitude and aptitude. Both are required, but I would say that attitude is really more important than attitude. Attitude is more important than aptitude. As this little cartoon shows, give me somebody who has a can-do attitude any day over somebody who maybe has the expertise but is just difficult to get along with. Now, back in Excel, we want to migrate from the D0 to the D1 tab, so we just click Next here, and it'll take us over to the D1 tab. And here we want to record the department, the name of the department, and the person who's going to be on the team and their role. And so let's work down these. The champion, that person ensures that the team has required resources and can remove any organizational roadblocks that the team experiences. The process owner, they ensure that the right team members are on the team. This, in many cases, is the person responsible for the manufacture of the part, although not always true, but in many cases it is. There's the project lead, and really the project lead's primary responsibility is to get the problem solved. So completing the 8 disciplines is their primary role. And then you have a process or a product supplier. Now remember, we're following the SIPOC method here, so we want suppliers, on the team, and these folks ensure that corrective actions don't conflict with required inputs. And then customers ensure that corrective actions don't conflict with required outputs. SMEs are subject matter experts, usually technical, although they could be very experienced people, and they have sort of detailed product or process knowledge. And then, of course, it's always a good idea to have quality representation on the team. They ensure that the tools used to find root cause are used correctly, and then others as needed. So let's go back now to the presentation. On to D2, which is problem definition. Well, there's good news and bad news in D2. The good news is, a lot of problems are solved here because we have miscommunication, we think there's a problem and there really isn't, or some sort of misunderstanding or bad measurement, misinformation, misuse of a part, this sort of thing. The bad news is, though, defining the problem is one of the hardest things we'll do in 8D, and it's really the hardest thing next to finding root cause. And why is that? Well, because it's considered trivial or a waste of time. I've heard many times, we already know what the problem is, why we're spending more time trying to define the problem. It is treated with sort of low importance and priority. The team is eager to get the problem solved. Management expects very immediate answers, or answers very soon after the team is formed, and of course customers want quick resolution. And so there is pressure on the team to move to a solution. Understand, though, that problems have to have a very specific format in order to be clear to everyone, and that's using a verb and noun format. So we have a few examples here: a broken spindle, mixed parts, missing thread die, wrong label, this sort of thing. I want to be free, the problem needs to be free or should be free of opinions and judgments, assumptions, presumed causes, solutions, blame, and this sort of thing. Many problem statements are expressed as solutions. That's the nature of problem resolution or fixing problems, and so we want to avoid that. Just stick to the verb and noun format. In order to define the problem, we're going to use an is and is not format. And so what is that? Well, we're going to describe what the problem is and what the problem is not. That's very telling. It does cover the who, what, where, when, why, and how, and it asks things like, can the problem be replicated and isolated? Is there trends that are observable? Has the problem occurred previously? It includes the scope, other relevant information, and then finally, based on the questions that are involved in the is not, the problem is described. Here's a few examples of problem definitions that I've come across. Now at the top, these are actually pretty good. Down below, they're a little more confusing. But broken punch, cracks on head, those are actually pretty good. If you look down a little further, customer found mixed screw with different pitch length, and it goes on to talk about a screw 9318. I don't know if that's quantity or a model number. I have no idea. So it's not clear what's happening here. And these, I would suggest, are not well-written problem definitions. So let's go over to Excel and have a look at what the is not looks like. Just as we saw last time, navigating from discipline to discipline, just click the next. And we come to D2, which is problem definition. Now you'll notice down the left-hand side we have the who, what, where, when, why, and that sort of thing. Okay, we have those categories, and in each we have what the problem is, and so who reported the problem. Maybe that was customer A and B, or Tom Jones, or that sort of thing. Who is affected by the problem, who is not affected by the problem, or who didn't report the problem. So in this case, we have customer A and B who reported the problem, and we had customer C who didn't report the problem, and yet presumably received the part. Any other information that you think is relevant, we record here. And I won't read all of these, but you can see where does the problem occur, where is it not occurring but could or is expected to. You could read that. When was the problem last reported? When might it reappear? What this is doing is it's forcing you to look at the problem from two completely different views to make sure that what you're answering, what you're giving as answers, is reasonable in different contexts. How often is the problem measured? How accurate is the measurement? And this sort of thing. And then down below we record other information. Can the problem be isolated? Can it be replicated? Is there a trend? Has the problem occurred previously? And this sort of thing. You'll notice here from the scope, customer, that's a link from a previous discipline. So the date, the part number, and so forth, you don't have to worry about filling that out here. It'll automatically fill itself out. Any miscellaneous information that you think is relevant. And then based on the answers to the questions above, describe the problem and or the opportunity. And again, keep in mind that the problem should use a noun-verb format, not have any opinions or judgments or assumptions or anything like that. Make it nice and clean and succinct and clear. Once you've done this, now I've done these many times, and once you've done this type of problem description, you'll find it very enlightening, very clean, and very assuring that you know what the problem really is. This concludes this part of the 8D methodology. For more information, you can go over to sigsigma.org. There is the Excel template that I've been using. It is there, and also an opportunity to purchase an ebook on the 8 disciplines, the problem-solving methodology. So thanks for watching the video, and see you next time.